we will directly move towards the simulation part of our um, like the renewable modeling. Okay, this is our the case that we have used from the sample case. Okay, next thing is that, okay, before okay, let's open the dir file. Now look at the machine data. Here you can see that there are number of generator with different generator model and then exciter model, as well as turbine governor and then stabilizer model. Then under wind machine tab, there should be the other model like the wind machine, and we need to add wind machine model for typical machine that is available inside. So for that purpose we need to add the wind dire. I think we need to pick. Okay, 1 minute. Okay, so now in this model we need to add the dynamic model. So first look at the dire file. So here you can see that the wind machine is applied at this 3018 bus, and also there is a three, the first one, the elect generator model, and the next like generic RE converter model, and then right after there is a user defined or electrical control model, and then there's a torque and pitch control model, and then the remainings are the same as we have discussed the gen row. And then the one more thing is that we need to turn off the generator like this one, the this 3018. This is available at from dire. We need to remove this off. I think this is available in this dire. Yes, here GG1, make it commented, and similarly stabilizer commented, and then exciter. Because we are modeling this in the renewable modeling, like through a user defined control, you can model implicit generator. The first thing you need to remember, in the case that we model in like in generic model. So if we are adding the only generic model, then we cannot do this implicit modeling. We need to do a explicit modeling in at that case. So here you can see stabilizer is off. Here is a UEL under excitation limiter is off, and one more thing is that GGOV1, this generator is also off. Okay, and next gen row we need to put it off. Okay, we are saving this model, and then we can open the dire again. Okay, one more thing is that we can make a conic and conet file. Why we can when we make this conic and conet, so it means that we can uh, access the any user defined model available in the dir file also. So that you need to mention any conic and conet, and then okay. Click. Okay, so still in machine, I think there is a issue with the dial. So last time I have yes. So let's check at the machine number and then we can move towards case 3018. Yes, because here you can see it's not written as a wind machine. So we need to first open the again the we need to open the case, because the in power flow the control should be at 2 for in order to modeling the renewable behavior. So the first thing is that check 3018. Okay, make it 2 plus 2 here. Okay, and then solve it. Okay, one more thing is that we need to mention the power factor also. That should be 0.95. Okay, one more thing is that the X source should be tetra 9. And sometime, because when we are modeling as a full converter model, then we should add this tetra 9 inside this one. Okay, make now we can save our case. Because in power flow modeling we have seen that it is necessary to model as a renewable generator, you need to set these control. So opening the dial again. Okay, make it the connect file and then connect file. Okay, here you can see that now these model are available. Okay, add this, these two model are available. Here you can see this is a control associated with the wind turbine, and also in electrical control there are different control. Mean in order to maintain the V flag, Q flag, and P flag, and then PQ flag. So I mean based on these control you can set different control, but in generic you cannot add these type of control. So I mean these control available with only these this model, and I will share with you these type of models. Okay, damping should be damping machine damping factor mostly we put at 0, so no problem. Okay, now the thing is that after that we need to convert our case and check in is initialized condition. So I have converted the load, and now we can convert our generator directly from here. Okay, convert, and then now we can go for the initialization. Let's check it's initialized. Now here you can see that it's initialized, so it's initial condition. Okay, now after that you can make a snap of this file, close it. So so save your snap file. This is our wind snap. Okay, and then we can go for data and channels. So only we are performing voltage channel, select buses. Okay, so we can define this bus, go, and then we can define other buses. And also we can from here direct from dynamics and channel setup wizard. So none, make it none, and then go for bus voltage and angle, and this voltage, and then branch. No need to measure this branch flows, only we are looking for the voltage at POI. Okay, so all voltages are created, then make save your snap file. Okay, now the one more important thing regarding the control. So we coming back to our wind machine, like the device model and then wind machine. So here you can see that if there is auxiliary control associated with this, then here the plant control. So here the complete auxiliary control available, that mean you can set the control from these model. So I will provide this dir file to you, all of you, and then you can see this reg, mean the what are the model, and if you are looking for the detailed modeling, like you can check the control diagram in PSSC manuals, and you can see the working of all flags, mean what type of flags involved in this auxiliary control. Like if we want to control the bus voltage of a remote bus, we can control from here. And similarly from a monitor branch, if you interested, sometime mostly we do, because in inverter based modeling that we perform only on the single machine infinite bus system. But here now, because we have taken the case of our sample case, and I have added the modeling of wind in the same machine, sorry, in the same case. So the first important flag is the VC flag, that is Drew flag. If it is put 0 with Drew, and if it mean 1, then it's line Drew composition. So it means that it should be 1. It means this flag, then the Drew will the basically the line drop composition will be involved to maintain the voltage. And similarly flag for V voltage or Q control, if it's 0 then it's on Q control, if it's 1 it's on V control. So it means that this plant is on voltage control, therefore we are looking at the voltage of the machine. So initial conditions are okay, you can see that here initial condition okay. We are creating any out file dot flat test, you can say flat, okay, flat plus disturbance. Okay, run for 1 second, then first make it 27, then 27 and make it 9. Okay, this is first second run, and you can see the voltages of different machines, sorry, different buses. And then right after you can go for a fault at the bus. Now apply fault near that bus. I mean, you can apply fault at the basically plant bus also. And also you can see the let's look at the connection to this bus, like 3018. What are the connections available? Okay, now here you can see that. So downtown and then west is available, so we can apply fault at this bus like 3008, and then we can trip this line, the highest, this one line from west. So it means that fault should be applied at 3008. So that we can check 3008, yes, this one. This is a 5 cycle fault, okay. And then 1.1, run it, and then clear fault. Okay, then trip line from 308 west, okay, and then run. Okay, run for next 10 seconds. Okay, it's closed. Now you can see, open the out file. Now you can see that the voltage is at, because we have initialized our case from this, and it's flat start, then 5 cycle fault, then came back. It means the voltages are controlled system. Now look at the voltage of our plant. Let's see. So first delete this one, because we have put our plant to the voltage control. Look at the plant voltages. You can see the voltages are same. I mean, like it's within range, like within 1 per unit. So it means that the same generic model, when replaced by a control, you can set different control. Once you will read the manual of PSSCR, and you will see different control are associated with this model in the auxiliary control. So I will provide you a dir file, and you can see the behavior, different flags inside this. So this is the wind modeling of our I mean the through a basically renewable user defined model. Okay, one more thing regarding the dir file. I mean, whenever you say user defined model, it will be here, you can say it written USRML. Otherwise you but in directly in a generator user written model, there is nothing about this, only the name is involved. But in user defined model, you add this USMRMDL user model for each. Here you can see that. So whenever these type of involved, it means that its auxiliary control will be associated. So it means this user defined model. And all these are the parameters. These are the first one, the flag like icons, and you can set different icons here under the dynamic tabs. Check, and you can see in this icons. So every control associated with the each model is available in the icons. In cons, these are the time constants and the values associated with the plant. Other than this, all are the basically the in icons, there are the control available. Okay, next. Okay, opening the case for the solar, and first before the solar we look at the PV RE file. Here you can see that. Okay, here this is a generic RE model for this 308, same model like, and we have switched off the generic for this. The conventional machine is replaced by a renewable machine of this. So again the RE converter model, then this is our basically electrical control model, and then the auxiliary control associated with this. Now here you can see that there are machine involved at different buses, like at 211, and then at 3011 and 3018, and this one. Okay, now look at the behavior. We have replaced all machines with, first we need to check the all machines code, either it is 2 or okay, go to machine, and then okay, check 101 here in. Yes, here you can see that not a wind machine associated with these, and these three are on a standard QTB and QB limits. It means this is control 1 and this is 2, and looking back at this behavior 201. So it means that it will take all automatically. Let's load the dir file. Okay, again define conic so that it will take user file. Okay, then connect. Okay, it means that there are three machines that are conventional and three machines are generator. Electric, like renewable machines. Here, look at the generator model and then electrical, because the type 4 solar model, and then direct auxiliary and control will be available. Now again, we can see this is a voltage control mode, and we are checking the voltage behavior. So first we need to save this as a snap file. Okay, snap file is saved, and the next important thing is that we need to define the channels inside this one, and then channel, go to dynamics, and then channel setup is only we need to check voltage and then uncheck and then none. Okay, this is finished, channels are saved, then make it the snap file. Okay, now important thing is that in the case you need to convert your case, convert your load, and then we can convert our generator also right after this. Okay, and then initialize it. Now check the report bar, initial condition. Okay, it means that the models are properly added. So this is the way to add the generic user defined model. The first important thing is that check the control of your machine, either it is at 1 or 2. If it is at 0, it will not taken as a renewable machine, it will be saved in the PSS will assume as a like conventional machine, and it will not, and there will be no initial condition. Okay, check. Okay, and next is the test flat test. Out file is this, and then run for, we have initialized this run for 1 second. Okay, again the bus fault at the same machine 3008. Okay, and then this, and then clear fault. and then trip line. Sorry, this is close. This is a trip line from 308 to west 305. Okay, so it means that we are creating a worst case scenario. We have applied a fault, and then after the clearance of fault, we are looking for a trip up line. Okay, now we can look at the dynamic machines involved at with model here with bus number 3018 and 3011. Okay, go to plot tree view. In this, here you can see the voltage control mode of the auxiliary user defined model is fine. It's perfectly fine. It means the voltages are within limit. And similarly, you can check other voltages. All voltages are mean the system grid. I mean that it's the voltage. All these plants are supplying enough reactive power at POI, and the system voltages are within range also. Okay, this is the modeling of like solar and the wind via user defined modeling, where we can see that the different diodes are available and the different control are associated with through auxiliary control, and these all these control model control diagrams including flags and the constants explanation in PSSC program application guide volume 2, and as well as the model you can check.